Hi learners, welcome to the course Data Mining, and our today's topic is Basic Concepts in Mining Data Stream. Myself Priyanka Gupta, working as Assistant Professor in Department of Computer Science and Engineering Data Science Department at IARE, Dundigal, Hyderabad. The topics I will cover today is what is stream data, its characteristics, what are the challenges of that, classifications of data streams, applications of data streams, DBMS versus SDMS, challenges of stream data processing, architecture of stream query processing, processing stream queries, methodologies, challenges of stream data methods, and challenges for mining dynamics in data streams. What is stream data and its characteristics? So the stream data is nothing but it is continuous, ordered, changing, fast and huge amount of data. Data stream is nothing but the data that is coming continuous, that is ordered, that is changing in the future, that is very fast, that is having huge amount of data. So that is nothing but data stream. What is traditional database? Traditional database management system, in that data is stored in finite persistent data sets. So this is the difference between the data stream and traditional database management system. The characteristics of database data streams: huge volume of continuous data it is having, possibly infinite data it is having, right? Either the DBM is having finite data, that is fast changing and requires fast real-time response. Data enters at a high speed rate. While we are storing the data which is entering, that is high speed in rate. Random access is expensive. If you are going to fetch some of the data randomly, that is very expensive to store. The system cannot store the entire stream. In the any computer system, that cannot be store entire stream, but only a small fraction. The data stream store only the summary of the data seen thus far. Most stream data are of pretty low level or multidimensional in nature, that needs multi-level or multidimensional processing, right? So the stream data is nothing but the continuous, fast and huge amount in the feature. So that is the data stream. So their characteristics were that is huge volume and that is continuous data. That is very fast. That is while we are going to store the data, that is very high speed in the rate. That to store that type of data is very expensive. So these are the some features of data stream. Challenges, it is having the infinite range, infinite length, because that is having the huge amount of data. So we can't say, because the data is coming as a continuous, so we cannot say what is the length of the data. So that will be the infinite length of data. Impractical to store and use all historical data. In that, impractically we need to store and we need to use all the historic data which we have stored, right? So that requires the infinite storage also, where we need to keep in which type of database management we need to store the data. So that it requires the infinite storage of that. Running time is also more and more while we are keeping the huge amount of data. The concept drift. As concept drifting, new features may appear. When the concept is drift, then new features will be appearing, right? For the data stream type of data. Concept evaluation. What is this? In this, new type of class normally holds new set of features, right? New set of class that requires having the new type of features. What is future evaluation? In this new features will be involving, because data is continuous, data is infinite in the nature. So the infinite data streams, that is normally and global feature is unknown, then only it is going to store. The new features will appear while we are uh, processing the data, the stream data. Classification of data stream, that uses past labeled data, that is nothing but the historical data. Historical data. So that data will come continuously, and that will be stored somewhere in the database management system, and then we need to build the classification model for that, right? So after that, it will predict the labels of future instances. While we have already made a model using that model, right? After that, it will be helping to take any type of decision for to use for to take any type of decision, a prediction. We at the final we can take the decision after the classification of data streams. At these are the three labels. So here are the some of the applications of data streams. In real world example we are using, the first is telecommunication calling records. That is nothing but that is the record calls is storing continuously at the somewhere. So that is also the example of data stream. Business data, in business data, credit card transaction details every time when user is using the credit card, then the transaction details will be coming in continuous nature. The network monitoring and traffic engineering. So what is network monitoring? If you, for example, if you are having the traffic data, that is updating continuously in the real time. So in that we need to monitor the network also. So that is the nothing but the network monitoring of traffic. Financial market data. In that, for example, we have taken the stock exchange data. So as we know, the stock market rates daily updating at the seconds that are updating. So that is also comes under the data stream data. Engineering and industrial processes. Here we have taken the power supply and manufacturing industry. In that also the data is updating as of now. So every time the data updating as the new type of items and new type of things are in the process, in the making of the process. So here also the data will be the data stream. Sensor monitoring and surveillance. So what is sensor monitoring and surveillance? That is nothing but the video streaming and video data, right? Video streaming data we can say, and if you are storing some type of video data, that is also coming under the surveillance and monitoring data. So here we will take the example of video streams. RFID is nothing but the radio frequency identification. For if we are going to purchase any item, there will be RFID to check that to take the identification of the item. That is also the data stream data. So that type of data also comes into the data stream data. Weblogs and web page click streams. So in the real time, if the user is clicking the web pages and anywhere, so logs are making. So all this type of data also comes into the data stream data. Data stream data. Massive data sets, even saved, but random access is too expensive. So all the massive data sets, what is the huge data sets, are storing anywhere, any on the any management system, are the continuous that are continuous in feature. That is also comes under the applications of data streams. So here we will take the example of a traditional database management system, and that we are comparing with the SDMS, that is Stream Data Management System. So in the conventional database management system, the persistence relations were there. but the in the data stream data management system, the transient streams are there, right? So this is the difference between them. In the DBMS, one-time queries will be solved at a one time, but here in the stream data management system, the continuous query is going on, because that is continuous in the nature, that is updating in the real time. In the DBMS, random access we can, and in the SDMS, we are having the sequential access of the data. In the DBMS, we are having the unbounded disk store, and the SDMS, we are having the bounded main memory. So that will be stored in the main memory of the disk, main memory of the computer. So in the DBMS, only current state matters. So what is the current status is there while we are writing the query, that matters the most. But in the SDMS, we are storing the historic data also. So here that data is very, very important while we are executing or processing the data. In the traditional or conventional DBMS, no real-time services were there, because we are having the database storage, and then we are updating using the that data while we are writing the query for that. In that SDMS, we are having the real-time requirements. So that are the main differences of that. In DBMS, we are having the relatively low updated data rate, and the SDMS, we are having the possibly multi GB arrival rate, multi GB arrival of data rate, right? In the DBMS, data at any granularity is changing, having. In the SDMS, the data at the fine granularity is having. In DBMS, we can assume the precise data. Because it is already stored, and we can check and we can work on the data, and we can fetch that type of data as a precise data. But in the SDMS, data is stale and imprecise, because it is continuous in the nature, it is real-time data, so data will be stale and imprecise. In DBMS plan, determined by query processor and physical database design. So here we are going to use the query processing while we are writing the query. But in the SDMS, on the other hand, it is having the unpredictable variable data, and that's variable data arrival and their characteristics. So that was the few features of the both of the database management system. That was how it was different, and why we are using this type of data while we are mining, and how we are doing we are applying the methods and algorithm on that type of data. Challenges of stream data processing. So while we are processing the stream data, what are the challenges we are having? What were the challenges we are facing? So first challenge is, it is multiple, continuous in nature, that is rapid also, time is also varying, and that is ordered streams. So the challenge when it will come, because that are all in the real-time example. So the data will be very, very continuous, multiple, rapid, time varying, and ordered. The SDMS stream data processing, it is calculating all the computations on the main of the memory of CPU. So that is also the challenges of that. The queries are often continuous. We are also writing queries here, but it is evaluated continuously as stream data arriving. So as the data is continued in the nature, the evaluation is also being continuous, because the data arriving so and so on, right? So the and after the query, we are writing the query. After that, the answer will also updated over the time, because we are having the continuous data arrival. For other challenges, queries are often complex also. Why? Because because beyond the element at a time processing is going on, beyond the stream at a time processing is going on, beyond the relational queries, that is scientific data mining, OLAP queries are going on. So that will be very, very complex, because the data can be very, very large in nature. The data can be very, very huge, and the processing will be differ while we are using the which type of data we are going to use. So that will depend on that. So that will only become the complex. The multi-level and multi-dimensional processing and data mining, in that most stream data are at low level, or we can say multi-dimensional in nature. So although that type of data, if that type of data will be there, then the challenges must be occur. Challenges must occur. This is the architecture of stream query processing. So here, as we can see, the stream query processor is there. This is the scratch space, or we can say main memory of the hard disk, main memory of the CPU, main memory of the CPU, or we can say disk and disk. So here the system is there, that we are having the stream query processor, and then the user application is using that, and the results after the query processing, the results is going to the applications or user. Here also, here we can see that these are the multiple stream of the data. These are the data stream, that is multiple in nature. So like this, we have to give the continuous query for the data stream, and then the result will be go to the user application. So that was the stream data management system architecture. Processing stream query. What is a query? Query, while we are fetching any type of data from the table, or we can say what is the data store, what is here, the data is continuous, so we have to write some type of structured query. So that is nothing but to style to fetch that query. Style of the statement we are going to write, and we are fetching the data from that. So here some of the queries there to while we are writing the query. One time query, we can say continuous query. So this type of query being evaluated continuously as stream continues to arrive. So we need to write every time one line query, one time query. So after the arrival of data, it will be updating. Predefined query, and we can say ad hoc query, that issued online. So that will be applied online, while we are not having defined query, predefined query. Unbounded memory requirement. So in that, for the real-time response, main memory algorithm should be used. Main memory, we are using the main memory for all the processing. So here the algorithm will also be used, main memory algorithm. Approximate query answering. So in this we have with the bounded memory, it is not always possible to produce exact type of answers, right? So because we are having the bounded memory, we are having the main memory, we will not be able to produce, or we can get the exact type of answer while we are writing the query for that. So approximate query answering will be needed for that. High quality approximate answers will be desired. So we will desire for the high quality approximate answers for that, because all the time the query will not be processed and it will not produce the exact answers. So that is the challenge also. Data reduction and synopsis construction method. So we will apply these some type of methods for that. These are sketches, random sampling, histogram, and wavelet. In that we have to reduce the data. So these are the synopsis construction methods we need to apply for that, and then we will get the approximate answer for the exact results. Methodologies for stream data processing. So the major challenges will be for that we have to keep track of a large universe. We can say large amount of data. So for example, there are pairs of IP addresses, not ages like that. So if you're having the pairs of IP addresses, so we need to keep track of this whole universe. This will be the large amount of data. Large amount of data. So what are the methodology we are using for that to keeping track of large universe? So first methodology is synopsis. Synopsis is trade-off between accuracy and storage, right? So this is the first methodology we can use. We can use the synopsis data structure that is much smaller in space, that is O of log k and space, and then their base data set O of n space. So we have to use the synopsis data structure. Then we need to compute an approximate answer within a small error range, right? So because we need to get the right exact answer while we are writing any query. So we have to compute we have to take the synopsis methodology, and then we need to take the synopsis data structure for the spaces, and then we will get the approximate answer, and for the within a small error range, that is factor epsilon of the actual answer, right? So like this the methodology will work. The major methods are for that random sampling, histogram, sliding window, multi-resolution model sketches, and randomized algorithms. So these are the some methodology we can use for the stream data processing. Stream data processing methods. So here in detail we will see the what are the methods we are going to use and what are the use of that method. So first is random sampling. In random sampling, that is knowing the total length in advance, in that we are using the reservoir sampling. So what is this? In this we need to maintain a set of S candidate in the reservoir which form a true random sample of the element that is seen so far in the stream, right? So as the data stream flow, every new element has a certain probability, right? So certain probability of that is replacing an old element into the reservoir. While in the reservoir we are having the all set of candidates. So here we need to replace an old element as a new element. So that was the reservoir sampling. Sliding window method, in that we have to make decisions based only on recent data of sliding window size, that is W. And also an element arriving at time that T expires at time T plus W, that will be the time will be added when the element arriving at T time. So the recent data of sliding window, that is of size W, and then it will be added with the when the element will arrive, that will be the T plus W. Histogram also one method, in that we need to approximate the frequency distribution of elements values in a stream. So here we need to find the frequency distribution for the element that is present in the data stream. After that, we need to partition the data into a set of contiguous blocks, buckets. So here we are calling as buckets. So again, here we need to partition that data after the frequency distribution. So what is frequency distribution? That is nothing but the data distribution of at frequency, right? So after that we need to equal width buckets. We need to make a equal size, equal width size buckets, that is equal value range for the buckets. So that is versus V optimal minimizing frequency variance with the each bucket. So we can apply both of these methods, first is equal width method and second is V optimal measure. Here we are minimizing the frequency distribution, right? So this was all about the histogram method. Now, multi-resolution methods. So here the popular models will be used like balanced binary tree, microclusters, and wavelets. So these are the some models we need to apply in the multi-resolution models. So this is also the method for the stream data processing. Here we are yes, this is sketches. So what is sketches? Sketches is the thing but the histogram and wavelets that require the multi passes over the data, but the sketches can operate in a single pass. So we have seen the in the histogram and wavelets method we need to require a multi passes over the data, right? But in the sketches we can have operate the single pass also. So the frequency movements of the stream A is equal to A1 to AN, and that frequency Fk will be Fk is equal to summation of V to I is equal to 1 Mi to K, like Mk to I. So where V the universe or domain size, Mi is the frequency of the sequence of I in the sequence. Given n else and v values, sketches can approximate f0, f1, f2 in order of log v plus log n. So this is the space that will be needed for that to store that. So that will be the O of log v plus log n space. So that is the storage where we will store the passes, single passes. Another method is randomized algorithms. So first algorithm is Monte Carlo algorithm. In that we need to bound on running time but may not return correct result. So that is the characteristics of the Monte Carlo algorithm. In that we need to bound on running time but may not be return actual or correct result. Another method is Chebyshev inequality. So in that we if for example let x be a random variable, if you are having a random variable with mean of mu and standard deviation sigma. So in that we need to apply this algorithm. We need to apply the formula for that. Chernoff bound. In that, if it's for example let x be the independent Poisson trials x1 to xn and delta in 0 to 1. So the probability decreases exponentially as we move from the mean of the values, right? So that was the Chernoff bound method. Challenges for mining dynamics in data stream. So while we are going to mine the dynamic data stream, so what are the challenges we will get? What were the challenges we will get? So most stream data are at pretty low level, but we can say also the multi-dimensional in the nature. So the for the processing we will need the ML and MD processing, right? So process this type of data that is multi-dimensional and also at the low level. So that needs the ML processing or MD processing. Analysis requirements are multi-dimensional trends and unusual patterns. If there are, then we need to analyze that. While we are having the capturing the important changes at multi-dimensional dimensions and their labels. So then also we can analyze that type of stream data. That will be the fast real-time detection and response. Then also we need to analyze. Comparing with the data cube, for that we will need similarity and differences of the data. Stream data or data cube, we can say stream OLAP. So is this feasible to use? We will use the stream data cube or we will use the stream OLAP. Is it feasible or we can implement it is as efficiently? So we will see. Multidimensional stream analysis. So here are the example of that. Some of the examples we have taken, like analysis of web click streams. So what are the web click stream? That are raw data at low levels, that is seconds, web page addresses, user IP addresses, etc. So here analyst wants to change the trend, unusual pattern, that at reasonable level of details. So the analyst that is going to change that type of changes and trends and unusual pattern, then only we will get the web multidimensional stream. For example, if the average clicking traffic in the North America on sports in the last 15 minutes is 40% higher than the last 24 hours. So that is nothing but the multidimensional stream of the web click data, right? So second is analysis of power consumption streams. That is also the multidimensional data stream. So here raw data in that power consumption flow for every household every minute. So as we know, the data consumption flow is changing as we are using the power. So here that will be the raw data as a multidimensional data stream. So patterns one may find. What are the patterns we will find after? Average hourly power consumption surge up to the 30% for manufacturing companies in Chicago in the last 2 hours today, and then that of the same day of a week ago. So that data is changing over the multidimensional stream. So here in the today's chapter we have went through the data streams. So there are multiple data streams we have covered, like there are data streams like we are having the click data, web click data. We are having the continuous data that is coming regularly from the manufacturing units. We can say the data that is from the sensor data that is coming from the video streams. So that we all have covered, and the process and methods, how we are going to process that data stream, how we are going to use the methods for that while we are going to process that. So some of the methods we are going to use, some of the data structures we are going to use, so that we have covered in the earlier slides. So here the multidimensional stream analysis example is there. So we have taken the two examples of that as the analysis of web click stream. So what is a web click stream? So that is nothing but the data stream while we are using the web pages, and then we are going to click the web pages on by the mouse click. So that also creates the notepad data that is nothing but the web click stream data. So the data can have the seconds, web page addresses, that can have the user IP addresses while the any user is clicking on anywhere. So that will store the many records of that at the low levels. That is we are taking the low levels data, that is second web page addresses, that is also IP address of the user. So this was the web click stream data. In that, if we are going to process that data, we are going to analyze that data. So what we have to get, we have to change the data. We have if some changes are there, we need to use. If some trends, we can say patterns are there, unusual patterns if also are there at the regional levels of details. So we will check the details of the data stream of the web clicks, and then we will need to find the other patterns, we can say changes, and then we can use that type of data. So for example, we can see here the average if the average clicking traffic in the North America for the sports, they have clicked for the last 5 minutes, that is 40% higher if we are clicking in the last 24 hours. So in the North America, the people are clicking the web for the sports, that will be increased in last 5 minutes. So that is also comes under the web click stream data. So that was the real example of the multidimensional stream. Another example also we have taken, like if we are going to use the power consumption stream. So what is the power consumption streams in the industry, industry, yeah, we can say in the some of the house, if we, the power consumption of flow, if we are calculating that, like if every household how much data consumption is using, and how much data, how much power is processing there. So the power consumption flow for every household every minute will be the raw data of the multidimensional stream data. So for that we need to find the patterns. What is the patterns the power consumption is using? Power consumption is changing per hour, we can say per click, per minute, per second. So for example, if there are average hourly power consumption, that will be rise as a 30% for manufacturing companies. If in the manufacturing industry, somewhere in Chicago is there. So in the last 2 hours today, so that has been increased by 30%. So then if we will compare with that the last same day of the last week, so that this type of data that is in the continuous in nature, that is very very real. So that is nothing but the data stream data. And here we can see the this data is having the uh, many dimensions, like some data is having the like power consumption data, some data is having the web click data. So that can be multi-dimensional data. So in the today's topic we have covered the all the processing methods, processing, how we are going to process the data streams that is coming as a continuous in somewhere, and how we are going to apply some of the methods to process that data, that is very very useful for us. So some of the methods we have also seen in the example. So like that we need to uh, need to check about the data stream data. So in the next topic we are going to see how the time series data will work. So here we have taken the data stream data, that was the advanced concept in the data mining, in data mining, and that was the types of the data, that was data stream, time series, some of the other data we will also take. So that was for all today. Thank you from my side. Thank you for watching.
Like, share, and subscribe. Hit the bell icon for more updates.